Today we'll do exercise 7.8, definite integration as limit of sum. We are doing from NCERT book, question number 4. So question is integration from 1 to 4 x square minus x dx. We have to solve it by limit of sum. Okay, let me write down the function fx. So the fx function is x square minus x, and I'm sure you must have a basic idea how does the curve look like. It is a quadratic function and it is upward parabola with the intercepts 0 and 1 anyway. So it cuts at 0 and at 1, and we have to find the area under curve from 1 to 4. So let's say this is 4. So basically we have to find this area. Okay, so the job is like from 1 to 4, the interval is 4 minus 1, which is 3, and this interval we will divide it into n number of rectangles whose width would be h. Each rectangle width would be h. So basically this 3 will be equal to n times h. N is number of rectangles and h is the width of each rectangle. Okay, and it is such that h is very small. Okay, and so n would be very large. If we put n number of rectangles, infinitely large number of rectangles, then width of each rectangle would be very small, right? So this is the important concept of this topic. Okay, now my job is to find the area of each rectangle which we are going to make inside. So the first rectangle which I am making, the first rectangle is starting from 1. So the height of that rectangle would be f1, right? f1. And what would be the width of the rectangle? Each rectangle width is h, right? So the area would be h multiplied by f1 plus. The second rectangle now I am talking about. The second rectangle width would again be h. This rectangle I am talking about. Okay. Width would again be h, and the height would be, the x value is 1 plus h here, right? So the height of that rectangle would be, means the length of that rectangle would be the y value for which x is 1 plus h. So it would basically be f of 1 plus h. Similarly, we have third rectangle, fourth rectangle, and the last would be nth rectangle, 1 plus n minus 1 times. Okay. Now in each of the factors we have h common, so we will take h out. What is my f1 value? I will write 1 square minus 1. We will not write 0. We will write 1 square minus 1. f1 plus h value would be 1 plus h whole square minus plus h. And like that, the third rectangle would be, we write 1 plus 2h whole square minus 1 plus h. And like that, the last rectangle would be 1 plus n minus 1 times h and whole square and minus 1 plus n minus 1 times h. So taking h out, 1 square minus 1, we'll keep it as it is, plus for 1 plus h whole square we'll start breaking it up. So it is 1 plus h square plus 2h minus 1 minus h plus the third term was 1 plus 4h square plus 4h minus 1 minus 2h. And similarly, let me write on one more term. It would be 1 plus 9h square plus 6h minus 1 minus 3h, right? And like that, would be 1 plus n minus 1 square h square plus twice of h and minus 1 minus n minus 1 times h. Hope it is clear up to here, guys. We have just broken all the terms, we have broken the square part, right? And then in the next step, what we do is we will try to resolve inside part. Okay, see what happens. So 1 square minus 1, I am not doing anything, plus in the second rectangle simplification is 1 cancels, so we get h square plus h. So this is all h, okay, it is not n, plus 1 cancels, so we get 4h square plus 2h, and from the fourth rectangle we get 9h square plus 3h, and like that from the last rectangle you can see here minus 1 and plus 1 cancels, so the square term is n minus 1 square h. Squares 4h square plus 9h square, and like that up to n minus 1 square h square, right? And then for the non-square part we are writing h plus 2h plus 3h, and like that up to h. Fine. Now from the first category, from this part, we are taking h square common from all of them. So we will write h square taken common, so we are left with 4 plus 9, and like that n minus 1 whole square, plus from the second part we will take h common, so we are left with 1 plus 2 plus 3, and like that up minus 1. Good, guys. Now we have h square. This is sum of square of n minus 1 natural numbers, so I am using the formula. So n minus 1 times n times twice of n minus 1 all over 6, plus, for this we are writing h taken out. This is the sum of n minus 1 natural numbers, so it is times n over 2, right? Okay. And then we get this all is limit h tends to 0 and n tends to infinity, nothing to worry. So now we'll bring all our h with n. So see how am I doing that? It becomes h cube n minus 1 times n minus 1 all over 6, and plus h square times n minus 1 times n all over 2, and this is limit h tends or n tends to infinity. Okay. What we will do, guys, we have h cube, so 1 h we will put inside the bracket. See what happens. What we will do, we will put h n minus h, 1 h we put inside the bracket, another h I will put inside this, and another h we will put inside here, over 6, plus here 1 h we will put inside the bracket, so we will get h times n minus h, 1 h we are bringing in, and another h we connect with n all over 2. And we have learned before nh is equal to 3, right? We have learned in the beginning in the question. Let me show it to you. So you can see here nh is equal to 3, right? So I will use that result. So it is 3 minus h bracket 6 minus h all over 6 minus 3 minus h times 3 all over 2 is equal to, h tends to 0, guys, please understand, right? So we will get 3 times 6 all over 6 minus 3 times 3 all over 2. So it is nothing but 6 cancelled. So it is 9 minus 9 over 2. We will get 9 over 2, and that is my final answer, square unit, because that is area under curve. Good. I hope it makes sense. Let's move on to the next question. Let's solve question number 6 from the same exercise. Question is 0 to 4, limit as sum. We don't need to worry about how the curve looks like. Okay. We will just find area under curve from 0 to 4. So my first rectangle would be the width of the rectangle, each rectangle is h anyway, and the first rectangle would be for f plus the second rectangle would be, the first rectangle was f of 0, the first rectangle, right? And the height of second rectangle would be, if this is 0 and this is width is h, so this x value is h, right? So the second rectangle height would be f of 0 plus h, which is just h. So I'm writing fh only. And the third rectangle would be, width would be h. This was the second rectangle. This is h. This point is 2h. So for the third rectangle, the height would be f of 2h. And like that, the last rectangle would be h times f of 0 plus n minus 1 times h. Good. Okay. Here it's important to mention my fx is x plus e to the power 2x. Okay. So, and h minus 0, the upper limit minus lower limit, is equal to n number of rectangles with each rectangle's width is h. So 4 minus 0 is equal to n multiplied by h. So 4 is equal to n times h. So we'll use that. Let's see. Limit h tends to 0. Take h common from all of them. So we have f0. Guys, f0 is 0 plus e to the power 2 times 0 plus fh. fh is h plus e to the power 2 times h, and f2h is 2h plus e to the power 4h. And like that, the last rectangle would be n minus 1h, so it is n minus 1 times h plus e to the power twice of n minus 1 times h. So limit h tends to 0, h bracket. Now guys, please see, we have one e, so 0 plus h plus 2h, and like that up n minus 1h. We will take h common from them. So h taken common, we are left with 1 plus 2 and all over plus n minus 1. Okay, we ignored 0, no use. This is e to the power 2 times 0 means e to the power 0, which is nothing but 1. Correct? Anything to the power 0 is 1. So now I am writing the e term. So 1 plus, this is e to the power 2h, and this is e to the power 4h. If you observe, last term would be e to the power 2 times n minus 1 times h. No issue. Limit to 0, that is h. H taken common, this is the sum of first n minus 1 natural numbers. So I'm using the formula n minus n over 2. Sum of n minus 1 natural numbers plus 1 plus, if you observe this, this is actually a geometric sequence. Every time e to the power 2h is being multiplied. So basically common ratio is e to the power 2h. So this is a geometric sequence, guys. So we are using the formula for sum of geometric sequence. So that will be, first term is 1 times r to the power n. So e to the power 2h minus 1 over r minus 1. So e to the power 2h minus 1. I use the formula a times r to the power n minus 1 over r minus 1, right? Okay. Then what we'll do, we'll bring this h inside. This h will bring inside. Okay, see what happens. And we'll do exactly the same thing the way we did before. Limit h tends to 0, and this h and this h makes h square, and one by one we'll put inside the bracket. So we'll get nh minus h times nh2. And then guys, this h will go with this. So we'll see e to the power 2nh minus 1 over e to the power 2h minus 1 times h. Good? Great. Now we know that nh is equal to 4. So here we can plug in 4. So the first limit set when limit h tends to 0 is 4 minus 0 times 4 all over 2. Right? Okay. And then plus this is, I'm referring to a limit formula. Limit x tends to 0, e to the power x minus 1 over x is 1, right? So I'm going to follow that. Basically it is e to the power 2h minus 1. So it should be divided by over 2h and times 2h, right? So this limit h tends to 0 is 1 based on this formula, right? And 1h and 1h. So we are left with e to the power 2 times 4. This nh value is 4. So which is e to the power 8 minus 1 over 2. And that makes e to the power 8 minus 1 plus 16 over 2, which is e to the power 8 plus 15 over 2. And that is my answer. So this is the end of limit of sum. Okay. Hope you understood. Thank you.